Welcome back. So now we go to the next task. We'll implement the dot tables command, which prints the names to tables in the user table SQLite database. So this SQLite schema dot table column. Okay, so this is pretty hard, and this is the one which we should, which forms the basis for the rest of the tasks here. So let's see. We should only look at the first page. We'll only look at the first page. Let's go. So SQLite page, probably need a page num, page size is also set. So what we have to do is cell pointer array, read the SQLite schema page cell pointer array, and that would come cell content area. Okay, so let's do this. Let's first finish up the header parsing. What do we have here for the header parsing? Think for the header parsing, 100 byte database header, 8 cell pointer array. So in the header itself, we got to this. Okay, we looked at the number of cells. Then at offset 5, we need to read the start of the cell content area. Okay, let's say this cell content area start. Okay, create field, it's an int. And cell content area is basically set at offset 5, right? So we have to go to 1 of 5. So let's seek to that. Page begin plus 5, right? Database file dot read a 2 byte integer. So read current. Okay. Let's reset that. 2, and we're gonna do this cell content area start. Then what do we have? We have the 1 byte offset fragmented free bytes within the cell content area. So that's at offset 7, right? Let's say fragmented free bytes. So fragmented, what's the name of this thing? Fragmented free bytes within the cell content area. Okay, that's fine. So basically, let's do current as, I don't think we need it like this, but we need to seek to page begin plus 7, I think. Right, so let's go to 7, then read that 1 byte. Okay, database file dot read fragmented bytes. Yeah, so this will only be there if it's a rightmost page pointer, right? Rightmost page. Let's call it -1 for now. It's only be there for interior pages, right? Also an int -1 right now, we don't care. So we have done parsing the header. We are done parsing the header. It's possible now we'll run into the cell pointer array, right? So this is where we'll start seeing the cells, right? So cell pointer. So there are 3 cells. Let's define the cell. Process cell pointers. Okay, create this. For int I is 0. Essentially, what we are saying is for each k be the number of cells in the B tree, it consists of k 2-byte integer offsets to the cell contents, right? So let's say int offset start. Okay, so we know the offset. Let's put it here. Now we also want to know the database file, right? So let's go to database file. Okay, seek to offset. The offset is going to be page begin plus 8 for now because the size of the header is 8. Header is 8 for leaf pages. We already skipped the for page num equals to 1. We already skipped the first 100 bytes of the database header. We don't care about this. So process cell pointers, we are here. So now what the format says is the cell pointers are arranged in key order. Don't care about this. The k 2-byte integer offsets to the cell contents. Right. So let's go put the private array list of cell content offsets. Right. This is what we got. Right. So let's read 2 bytes for this. So for int I is this. So I think what I'm going to do is I'm going to have a read 2 bytes method here. Right. It's going to be offset. Probably have to be long offset, I think. Then we throw an exception here. We seek to this. Now you read 2 bytes, which is probably going to be this. I think this is what we'll do. We copy this here and put it here, and instead we return this. Okay, don't care about this. This is what we want. So cell content offsets dot add read 2 bytes from offset, and then we're going to do offset plus equals to 2 because the format is saying that k 2-byte integer offsets to the cell contents, right? The cell contents, we've done it. Now we should read the cell, right? We have the cell pointer array, so we process that. So this is the thing. So we'll need to read the B tree leaf cells. This is complex. This is the key. This is where we'll run into the parent construct of SQLite. Variants are big endian. Bits taken from the earlier byte of the variant are more significant than bits taken from the later byte. So this big endian versus little endian stuff is a little confusing, I think. Okay, so let's define the cell then. Right? Let's define the cell. Warrant, the initial portion of the payload, which doesn't spill to the overflow pages, and the 4-byte big endian integer page for the first page of the overflow page list. Let's do that. Let's go and define a cell. Let's call it SQLite cell. Okay, so a cell is a warrant, but let's also pause for a bit. Okay, we're back. So warrant, which is the total number of bytes the payload. Let's define the warrant class. Okay, we're not going to use this. So the cell saying it's var int is the total number of bytes to payload. Okay, total number of payload bytes. Okay, then the row ID. Let's go. Var int row ID. Then initial portion of the payload, which runs till to the overflow pages. Maybe I track that as the offset, or maybe yeah, I think that's what I should do. I should track that as an offset, right? Payload offset. Let's call it payload offset relative, relative to the current from the beginning of the page. So, and then 4 byte big endian, big endian page number for the first page of the overflow list. I should put this as long. Page, overflow page. Okay, probably not needed. Let's say it's -1. Only there for overflow pages, right? Not overflow pages, only there for pages which span multiple pages, right? So we don't care. Most of them for the, I think for this assignment, we don't need that. So let's do the warrant. Now this is, if you go here, you will see that the record format is also different. But first, let's look at this warrant business, right? Like this is key for how SQLite stores data. So our warrant basically is a uh, something like this. Go to the official documentation. They talk about warrants. So where is the warrant? I think that's what we want to talk about. Warrant, yeah. The static Huffman encoding of 64-bit 2's complement integers that uses less space for positive values. A varint is between 1 and 9 bytes in length. Okay, the varint consists of either one or more bytes which have the high order bit set followed by a single byte with high order bit clear. So essentially what this thing means really is that let's say we have something like this. Okay, 1 2 3 4 5 6 7 8 bits. 1 2 3 4 5 6 7 8 bits. Bits 1 2 3 4 5 6 7 8. So you have 9 such things. That's 1 2 3 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. So varint can be 1 2 3 4 5 6 3 4 5 6 7 8. I think this is 9. So 9 bytes. 1 2 3 4 5 6 7 8 9 bytes. Okay. This is the max length of a warrant. Now, whether or not uh, this byte, I mean, whether or not the warrant spans the whole 9 bytes depends on the first bit of each byte. So let's take, for example, this one. If it's like this, and you have something like this, now the rest of the bytes will not be there, right? You only have these and this. It's only 2 bytes long. Okay, so similarly, 2 bytes long, full 9 bytes. Okay, Uh, it all depends on the first most significant bit of the first byte of the byte, and then you see if the next byte is there by looking at the first bit. So the way to decode warrant is decode warrant is look at the most significant bit. Okay, so if it's one, let's call this as MSB. If MSB equals to 1, then there is a next byte that I have to decode, right? There is next byte as well that has to be decoded. If MSB is 0, I mean, there's nothing else. There is nothing else, right? Except for the last byte. So that's what this also talks about. Warrant consists of either 0 or more bytes, which have the high order bit set, followed by a single byte with high order bit clear, or 9 bytes, whichever is shorter. The lower 7 bits of the first 8 bytes and all 8 bits of the ninth byte. So if a warrant is 9 bytes long, then you have to consider the last 9 bytes. Okay? As full. Last ninth byte as full, basically. This is a little bit of a complex algorithm. So let's see. To offset and public void build warrant. Okay. Public long build warrant because so the max width of a var int is probably going to be 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 7 into 8. It's 56 bits plus the last, which is 8 bytes, right? So that's going to be 64 bytes, 64 bits. 64 bits is a long in Java. Okay, so this is the max width of a variant, right? So now this thing is a little bit tricky to unravel. We know the offset, so the way we can construct the variant is uh, let's call it return. Okay, basically 0. You need to start reading, collect the first byte from this offset, then read the next set of things, then read the next set, next byte, next byte, next byte, something like that. And I think the way variants are big endian. Can I use ChatGPT to tell me how to decode variant? Let's see. Decode var Java SQLite. Okay. All good. Read variant, data offset, byte set 0. Okay. So this is exactly what we want. Right. So you read the byte set is 0, offset plus I is greater than data is and 0 xff. Last byte contributes this. So we can, I think, pretty much copy the whole thing as it is. Right. So let's see. This is what we want. This byte data is going to be our file input stream. Okay. Read 7 bytes. So let's say that we return the offset plus this, right? Okay, all good. So let's see if the thing that this guy ChatGPT gave is correct for us. Let's go decode the cell, right? So we look at the first cell and then right page, cell content offsets. We looked at the cell content offsets. So let's get cell in cell number, return. No, let's actually build these cells. Okay. So cell content is stored in the content region of the B-tree page, right? So for each of the for cell content offsets dot size, okay, we will start new SQLite cell. Then for this we need to get the offset. I think let's set this up. Let's call this okay payload offset size relative. Right, this is really what we want. Public SQLite cell long content offset. This start payload is offset. Okay, set it like this. Private. Want this private. Okay. Cell content offset. Let's call this as long. I think. No, maybe not. Should be integer. What happened? Oh, there we go. Array type expected. What is that? Okay. Coming from C++. Okay, so cell dot. Okay, build. Now we and then let's say we capture all the cells here. Right, so let cell and add cell. Let's go. Let's do whatever this thing is asking us for. You know what? Actually, we can do cell content offsets dot stream dot map teacher of new SQLite cell content offset, then dot collect. So let's just say to list. Okay. What we are doing is cell dot build return cell and then this is exactly what we're doing. Okay. So we build the cells for each cell. Now this is where we have to go and actually decode the variant. So let's do that. So total number of payload bytes equals to var int dot read variant. The offset is payload offset relative. But what's the data for this? Where do we get the data for the cell? Right? I think this has to come from the page though. It has to come from the page, I think. Hmm. So can I assume that the cell content always, maybe this is how I have to view move this as. Move the cell into the move the cell class into the page. Mhm. Mm. Why give the page for this? The page actually has data. Let's put it that way. Oh, it's actually a byte array of data, right? Uh, this page basically exactly has page. Okay, so what I mean is data equals to database file dot seek page number minus one star page size, right? So we go there and then read page size volume of data, right? Now database file dot read uh, data equals to new byte page size. So I'm gonna capture, yeah, there we go. So we read each byte, each page of the database file this way, and then we give this to the cell, I think. Let's call it cell number. Okay, we go give it to the cell number and then we pass along data for this, right? So, okay, so we got the var int data. This dot total payload bytes is var int data of 0. Okay, I think we should just call it as long. Let's do that instead of roll. Then, what is the thing saying? It's the row ID, right? So let's go read the next one. Our data is again read variant payload offset relative plus the second one, right? Because it's shifted to the second one. Maybe not. I think I can cast this to int. I'll just cast this to int. Because that's really what I want, though, right? Offset plus byte set. So this offset is always going to be less than the size of the page, between 0 and the size of the page, for sure. Right? So what we are saying is the offset is always must always be between 0 and the size of the page. Which is the into the data, right? The actual page. So page in SQLite, what they are saying is the max size of a page is maximum data page is at 65536, right? So that's the maximum page of the size. Okay, max page size. This is what it is. So I don't No, but the value can be long. That's the problem. Okay. Okay. That makes sense. So you know what? Instead of this, let's do it like this. Private long content and private int and offset and sort. Right. So let's return this. Right. So it's going to be long content int and set. So let's say this content. Okay. So let's do a return you are in value and this. Where? Let's go to our, let's read it as var int dot content, right? Okay. Hmm. Not get content, dot get end set. Right, so let's go just create that. Okay. Okay. So we get the now row ID is var int data dot get content. Much better. And then the actual record, right? So we'll have to decode the record. But before we get there, let's only look at what we've done so far. At test, at ignore. Can I not just skip this thing from erase that? Dot sh. Skip test. If I do this, I think it'll work. Right, so let's not do the ignore. Or test cell read cell content. Right? This throws exception. So we are also going to continue doing the same thing here, but here we are at parse header. Parse header is reading the process cell pointers, and then we call build sets. Right? Now let's see. Let's see what's happening. I'm going to print the. If nothing fails, at least then it works, right? Let's see. Oops. Cell content offsets is null. Why? Why? Cell content offsets, new array list. So let's also do the same thing here. K. Unexpected end of data. So we have a problem. What's that? GPT failed us. Let's see. The reason I went with GPT is because the bit twiddling is a bit harder to get right. So let's go and see what is happening here. Let's put a breakpoint. You know, one of the best things about Java is the debugger. You just go. Okay, so cell pointers, let's see where we are at. 3779, 3901, 3983. Not bad. Let's go here. Is this the one that we want? I think what they're saying is it starts from 78, right? Yeah, I think this is the reverse. Hmm. Why is that a problem? It read the variant. Okay, the content. So this is where it failed. I think I can just remove this, right? We need the payload offset relative. We probably don't. There we go. Fast, fast. Let's print the cells. Let's see what the toString is. Right, I wanna let me just generate the toString for this thing. ToString, let's see. In the test, what I'm going to do is out page dot not have any of these as private. Hmm, SQLite cell, get cells, return cells. Right, so let's go print them. Page dot see what the complexity is. Okay, so we have payload bytes 120. So payload offset relative is 309. Overflow. We don't have overflow pages for any of these. Okay, so 120 is the third cell. It actually read it proper, right? Row ID is 03. Read the row ID as 3. We are good. Okay, so the var int decoding logic is correct from ChatGPT. We don't have a problem there. Good, good. ChatGPT is doing God's work for me. Okay, so I did the cell. I have the whole thing here. I have processed the cells. Now, what's the next step? I need to read the record format, right? Yeah, let's do that then. Value of each column of the record in the order. So this is a little bit complex. Oops. What happened? What happened? What happened? Damn. So we are at first the header, serial type, each column in the record, and then the body of the record. This is the value of each column of the record. Depends on the serial type. Let's go and build the record format reader then. Let's do that. Let's say we parse or build record format, right? Reach cell, payload offset. This is where the cell is starting from. Let's call it as start. Okay, so that's the start of the cell. Add data.get content, and then we get the cell content area start, right? Record format, record area. Let's say payload area start. This is actually set here. Let's do variant data.get end set. Right? So payload area is starting right at the place where the row ID var int is ending. So let's go and decode it again. This is what we must be getting, the size of the record header. Okay. So var int record header size is var int dot read var int data comma sorry, not this. Yeah, actually byte array data comma payload area start. So we get the variant. So let's print this and see. Get content. So if everything were to be correct, I must be getting the size of the record header as 7. Right? Let's see. Fingers crossed. Hmm. Oh, okay. So nobody called the this method. Let's do that. Stream dot for each. Where do I get the data from? Build record format, and the data is page dot get data. I think this is what I need to do. Return this dot data. Okay, so let's see what happens. Things are right. At least it should print the first one. For the last cell, I should get the. Okay, there we go. For the last cell, we got 7, which is correct. And now the next set is what we have to decode. Right? So what SQLite says is the body is here, the record format. It says the key of the index page. We're not worried about the index page key right now. We're only looking at this. The payload, either the B tree data or the index B tree key is always in the record format. The record format defines a sequence of values, a header, and a body in that order. The header begins with a single variant which determines the number of bytes in the header. So there are 7 bytes in the header, right? Uh, I can't bytes. There are 7 bytes in the header, and what this guy is saying is the size of the header in bytes, including the size of the variant itself. So the current variant size, the size of the variant are one or more additional variants per column, one per column. So the rest 6 of them are actually things that we really care about. That's what we need to look at, right? So the way we can do this is for the whole header, we decode it this way. Let's call it as record header start. Record format header start. Okay. So the record format header will end at start plus 7 bytes plus record header bytes. Right? Let's say that end equals to record header start plus start and set, or actually get content. This is where it will end. The variant is actually, yeah, I'm not so sure. What is it saying? So it started here. The record contains the header begins with a single variant, which determines the total number of bytes in the header. Total number of bytes in the header. Nah, so variant value is the size of the header in bytes. So, okay. So can the size of the header be? Oh, it can go beyond multiple pages, right? So if there is overflow pages, we will have it is a problem. So you have to treat that as the total header size can be long and not an integer. Hmm. Number of bytes in the header, it is long. Shall we? This is also actually long. Probably going to fail here. We should put it as long offset. But I'll cast this as int. I think this is going to be a problem, but let's see. Uh, yeah, it's not the right thing. Int is within this. The header is also ending at some point. Yeah, this is no. Hmm. Okay, a little confused here. So this is the header size. Header begins with a single warrant, which determines the total number of bytes in the header. Okay, the warrant can be a 64-bit long number, right? Now that means that it's basically saying that the header can also be 64-bit long number. Size of the warrant itself. Following the size warrant, I think I should treat a warrant as a long pretty much. Long, which determines the number of bytes in the header. The long value is the size of the header in bytes, the size of the warrant itself, following the long size long or one or more additional longs, one per column. For the page, zeroth page, you can pretty much treat it as, I think this one is a little bit more complex than it. Hmm. In the SQLite schema, there are one, two, three, four, five columns, right? So let's basically keep this here. Let's put it like a. So you have five columns for the SQLite schema cell. I have to read it as that, pretty much, right? I parse the SQL. I mean, number of columns are basically going to be five. I think I can put it this way. Okay. Equals to num columns, but it's pretty much five for. You can put it as five for this. Right? Let's keep it five this way. The rest we'll see. The next set of challenges. We'll see how it will look like. Okay, so the way we can now start doing this is read the. No, no, it's a little more confusing. Should actually be having header begins with a single variant. Okay. Total number of bytes in the header. Okay. 2, 3, 4, 5, 6 plus 7. So I'll decode the can the size of the record header be? It can be though. Can be like a million, can be a billion as well, right? I mean, if you store a very, very long string, it can just go beyond whatever is the integer width. The size of the header has to be a long, technically. I will treat variant as a long, pretty much. So I have the variant, which is long. Then the serial type for this, it is saying, but how many variants should I read? That's the question. I think for the sake of the first one, we can read 5 variants, right? One, two, three, four, 5 variants. Hmm. Like, how does the overflow page look like? We'll need the overflow page. Overflow page form a linked list. The first, which is the page number of the next page in the chain. Let's say I store like a very long text in this page. How will the overflow look like? Like, does it? Guess it depends on the columns, though. Hmm. How do I decode this? The record header size it's saying in. Let's put it this way. Header size is record header size bytes dot get content, right? Right. This is what we have. Let's keep reading parents, right? Parent next is basically variant dot read variant data comma record header size. Let's put the offset as something like this. Dot get and set offset. Okay, you got the offset. So offset is next dot and set. Let's print this get content. Now, when do I break out of the while loop? When do I break out of the while loop? I think I need the size of the byte set, right? Let's do that. I think this is what I have to do. Hmm? Let's put a constructor for this. Okay. And then let's do this data and int offset. Right, so let's say we do read warrant data comma offset, and this ought to be the one. We don't return anything. Right, so we say this dot size is byte set, this dot and set is offset plus byte set, this dot content value. I think this is what I have to do. Say new var int. Say new var. Same thing here also. I think I'll just treat it as a new var int. Okay. So when the when it's going to break out is if the header size is 0, right? Is greater than 0. Pretty much when I break out. So read the warrant header size minus equals to next dot content size. No, not content size. We have to add a getter for this one. Next dot get size. Build record format. I think this is what has to done building. Okay. So it has to be. Let's see. Okay, it looks like this worked, but I'm more interested in what the hell is happening here. We don't care about the cells. Let's not do the. We build the record format for sure. Hmm. So let's get the third cell and see how it looks like. Right. So uh, two. See what this means. That's the second cell is what 120 payload offset. So let's see. Let's look at the content of this damn thing. I'm more interested in the cell content itself. Okay, num columns 5, record format header start. That's not so bad. We want to build record format. Let's see. Cell number. We put a cell number as well. Hey, no, it's already there. Do we get the index in the map? Java stream list get index. Is that possible? Hmm, not so bad, but I think I'm a little bit more. Okay, much better. SQLite cell, new SQLite cell, cell content offsets of I, much better. Comma, num columns is just stick with 5 for now. I think we can, it's probably redundant. Then it's the cell number, right? What is cell content? Okay, that's okay. What the hell is this complaining? Cell dot build data, then cells dot add cell. Let's remove the rest of this stuff. Why the hell is it failing? Okay, man, it's not so bad. And now we can do some stuff. Three or two, right? See what happens. Shit. Just wondering why it didn't break there. It must break there. Okay, now it broke. Okay, so the data is here. The offset is 3781. Oh no. 3779. Okay, perfect. Total number of bytes is 120. So let's see. Header size 7. Offset. What is next? 23. Is it the same here? 23. Okay, we are good. The next one is also going to have to be 27. 27. Perfect. So what's the next one? 27. 27. Okay, wonderful. Schema root page. This is what we should be getting next. 1. Okay, awesome. Schema SQL. Schema SQL 199, size 2. Wonderful. So we are done. This is perfect. It's working like a charm. Now let's do the serial type to data type processing. Actually, you know what? I only think we care about this one, but um, we need the whole thing. We only need the table. Okay. So how is this gonna look like? SQLite page, we built it. But we actually need the serial types, no? So let's go do the serial type thing. Yeah, this is the one that is important for us. Capture this. So we need this. This is absolutely needed. Needed. Public static serial type. Okay, it's a bit difficult to read. Bit difficult to read. Content size. From content size, I need the serial type. Okay, so I'll create a serial type enum as well. Serial type. Serial type is going to be null or 8-bit. Okay, let me always just copy these things. Null, 8-bit 2's complement integer, 8-bit integer. All integers are 2's complement. Let's just assume that. Okay, 8-bit. This is 16-bit. Okay, this is 24-bit. 24-bit, 48-bit. Then we have 64-bit. Okay, 64-bit. I think we should probably. Then you have 64-bit or bit integer. I think this is what it's going to be. 64-bit real. Then you have integer 0, integer 1, and variable for internal use. So I think we don't care about this. Got blob and text. Okay. This is the serial type from content size. I think this is where I need some help from ChatGPT. I don't want to put a switch case. Let's do this. Let's give it to ChatGPT and ask it to generate for me. Uh, Generate the method, finish the method. Method. Here is the serial type enum. Okay, just go get the serial type enum, give it to our ChatGPT and ask it to generate. Come on. I didn't ask for all of this. Okay. But I think I need the get the lengths as well. If you're mapping from serial type, No, this is not what it is. I think I get the serial type, and then from the serial type I need to get the content type. This is what I want. Yeah, I think this is what I want. Let's use this. Thank you, ChatGPT. Is that failing? No. What's the format? N is greater than or equals to 12 and even. It's blob. 13 and even. It's right serial type. What we also want is content length. Yes. Perfect. Serial type info, size, this is perfect. Serial type code from serial type, usage example. Yeah, this is what I want. My man, ChatGPT, you're awesome. This is what I want. Mm-mm. Okay, where is the. This is not a class though. What the fuck? Refactor this and rename to maybe put it as private. I don't understand this. Why is this complaining? No, 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 no. Oh, my man, this is what you did. This is not what I want. I want this gone into this. You know what? ChatGPT does some shit like this. Okay. So we are here, serial type info. I'm now in this cell. Uh, let's get next dot get content. What I'm actually getting content for is the content size, right? Or I'm getting the serial type. Getting the serial type. That's what I'm getting at. Okay. So serial type info dot from serial type code serial type. This is what I want. Perfect. Serial type and the size. I have everything. Uh, the cell should have this. Mm, okay. Type info. So now we built the record format header, right? Done building record format, body offset from. It's where the offset is starting. So let's see. 3789 is where the body offset is. So I need to go and basically read for each cell what's the serial type info at um, probably 012. That's what I need to do, right? 2. This is exactly what I need to do. Hmm. Print content at index, and obviously I have data, byte data. It's not index, it's actually the serial type index. Yeah, comment offset. So basically, what we are saying is for this type index, serial type info list dot get serial type index, right? The thing is, from the offset, you have to skip those many. How many of those should you skip? And you have to skip byte zero. I mean, this is the data. You know the offset where it is starting from. The cell content is starting from. Let's call it payload offset, or let's call it record body offset. Now I'm saying give me the content at index serial type index 2. That means that I need to skip to the offset at 2. So let's call that out. Skip 2 is record body offset for int I equals to 0, I less than serial type info list dot size. I have to skip 2 plus equals to serial type info list dot get of I. Or I should just skip to this index basically. That's it. Right? So dot size. And then I read the content in a byte array, serialize it as whatever is the content. So let's read it as a text, right? Mm, Data of skip 2. What is the byte buffer? Byte buffer. Byte buffer dot wrap dot get string. I think that's what I have to do. data, comma. Oh, this is pretty good, man. We have a array offset and length, right? So skip to comma length is serial type info list dot get of I dot size is what I want. What I want dot set a byte read array. I think this is what it is. I think I should be able to do this. Should give me print content at cell dot print content at the record body offset is something which I'll do. I have to pass the record body offset? Actually, correct. Leave mode as public. So 012 is the serial type info. Then record body offset is what? 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 Let's set the record body offset here. I don't think we need the num column. Let's remove that thing. Sounds redundant. Change that. Right, so let's put the record body offset as well. The record body offset is actually coming from offset. We don't need this anymore. Okay. So if this is -1, I'll just throw an exception saying that, hey, this is -1. So new runtime record body offset is not set. Maybe you forgot to build the step. Okay. Perfect. So let's see if our test is working. Print content at I think build record format header is being called already. So print content at page.getData, comma 012, comma that's it. Nothing else. We don't need to do anything here. Let's go. See what happens. Uh-oh. Not so good. It's horrible, horrible, horrible. Why? The data is still. Is this what it is? Should I just skip to page number? It's actually cell. That's correct. Okay, so not bad. The serial type info list is 6. 57719352. What is 52? Why do I have 52? And this is the problem. 96 should be there. Regardless, I think record body offset, read the from 3801, read. Yeah, so what's wrong with this? that a problem? What? If it's string, do I really care about the? Yeah, I don't think so, man. So let's see. This is the size of the array. Now I start from skip 2 and then I go to I actually 0 I less than d dot length I plus plus, then d of I is data of skip 2 plus plus. This is it, right? What I'm really looking for is this. Will it work? Why the hell is that? What is skip 2 saying? What is body offset problem? It's correct though. It's coming from 74. Oh, okay, okay. There's a problem here. It mustn't skip the whole thing, I think. Okay, I got what it is. I think it's probably doing a double thing. Hmm. What is happening here? Let's go. This is not what? Didn't record format. Am I not setting the cell number? Uh, okay, sorry. Probably the case. Let's see. Header size is 7. Header size is greater than 0. I think this may be the problem because we skip the. Hmm, that may be the problem because we're not including the header content, I think. Alright? If you just say header size equals to record header. No, no, no. It should decrement the current var in length, right? Header size bytes dot. This, this is probably the way we should go. Hmm. Yes, sir. I think now we are better. But still we failed here. It's a massive bug somewhere. We do have it, but What's happening? What's happening? 3788 is the offset. Okay? 3788 is where it is starting from. Right? So I'm basically skip to 0 and 1. This is all I want. 12. 3788 plus 10 is 3798. Like, size of this is 5. Okay. Okay, that's correct. 38 perfect. Like, what am I? Hmm, 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 hmm. Okay, we have this. D of I is data of skip to plus plus. So new string D. What happens? Yes, this is exactly what I want. This is exactly what I want. Right? This is perfect. Hmm. Wonderful. So let's do the whole thing, right? So page dot. This is what we are saying. And apples. Okay. Okay. Sounds good. Sounds good. Table name. We can do this. Right? Let's do these. Now I think we should print the whole table. Apples and oranges. Perfect. Let's go to main. We'll submit the damn thing. Database file path. Oh, there we go. There we go. We printed this. I think, let me just copy the whole thing from the test. Print it like this. Should be working, I think. Hmm. Page dot get cells dot for each this. So let's go and see how it works. Let's test. I did skip tests though. Hmm. The next ones are going to be a lot harder. Uh, what? Why? Resource sample DB not found, but I skipped tests, man. Why is the test even getting executed still? Gonna have to ignore this thing. Okay. What has happened? Hmm. I think S is small here. What's the problem? Okay, passed. So let's do submit. This is actually pretty hard. From here, we'll do the rest of the stuff. I think this lays the foundation. Count rows in a table. All of this involves parsing the create equivalent queries. So let's do. We'll experiment with Antler. That's how I did it with C++. plus plus. Okay, wonderful. So on to the next one. Uh, Mark stages complete. Count rows in table. So count rows in table. I think from here we are getting into SQL territory. How does a query actually get executed? We'll resume this sometime later, but until then, have a nice day.